Okay, this video is going to cover Chapter 5, Section 6, and it starts with the warm-up to review what you guys covered in 5.5. So it says to write the angles in order from smallest to largest using the triangle that's drawn. So if you notice that these sides are 11 and 9 and 6, if I go in order from smallest, then I would go opposite the smallest side. So smallest side is 6, which means angle X is going to be the smallest. And then next largest would be 9, which is opposite angle Z. So angle Z would be next. And then the last one would be 11 is the largest, and that's opposite angle Y. So that's going to be your largest. Number 2 says the length of the two angles of the triangle are 12 and 9. Find the range of the possible lengths of the third side. So remember that you want to be able to find the difference and the sum. So the difference of 9 and 12. 12 minus 9 is 3. So it's got to be bigger than 3. But then it has to be less than the sum. So 12 plus 9, which is 21, means that it has to be in between 3 centimeters and 12 centimeters.
And converse of Hinge theorem. Now, what this literally says, if two triangles share two congruent sides, so the side lengths of one triangle is congruent to another side length, and then another side length of your original is congruent to the other side length of your other triangle, that you can look at your side lengths that are left over to see which one is greater to find the greater angle measurement. You can do the same thing for looking at the angle measurements to find the greater side length.
So if you look at the diagram that's here, this one's called the Hinge theorem, and the Hinge theorem says that if you've got two pairs of sides that are marked as congruent, so AB is congruent to DE and AC is congruent to DF, so you have to start with two pairs of congruent sides. Then if you look at the angle that is in between those two, if one is larger than the other, then the side opposite the larger angle is gonna be smaller than the side opposite the smaller angle. So if you could picture actually two sides and this in between, the wider you spread this apart, the longer the side opposite becomes. And the smaller you shrink this angle, the smaller the side opposite comes. So if you think about, like, the hinge of a door, or if you had two pieces of wood connected by a hinge, the larger the angle, the longer the wood that would be to connect them. And the smaller the angle, the smaller. So that's where this Hinge theorem comes from. And then the converse of the Hinge theorem says, again, same beginning, two pairs of congruent sides. But this time you're saying that if the side opposite the included angle is larger than the other side opposite the other included angle, then you can make the conclusion that the angle opposite the larger one is bigger than the angle opposite the smaller one. So let's go through some examples. If you look at A, it says use the Hinge theorem and its converse. It says compare angle PQS, so PQS is this angle up here, and angle RQS, which is this angle here. If you look at this diagram, you have a reflexive side with QS. So in each of those triangles, if you would split those apart, each of them would have QS, which means you have one pair of congruent sides. And then you have 7 and 7, which means you now have two pairs of congruent sides. Now, I don't know anything about the angle measurements, but what I do know is opposite that purple angle is 5.3, and opposite the blue angle is 5.1. Because 5.3 is bigger than 5.1, I can say that the purple angle, or angle PQS, is bigger than angle SQR. Which is what this says right here. If you go to B, it says compare KN and MN. So KL is here, MN is here. Again, if you look, there's two triangles there. They have a reflexive side, so you've got one pair, and then they both have 6 as the outer pair. So that's two pairs of congruent angles, congruent sides. This time we know information about the angles. So 53, which is opposite KL, and 57, which is opposite ML. Because 53 is less than 57, you can say that KL is less than MN. Example C says find the range of values for Z. Compare the side lengths. So again, if you look, you've got your reflexive side. You've got this time the two congruent sides, which are out here. And then we're looking at the angles in here to find the relationship. So 6Z minus 3 and 45. And the opposite the 6Z minus 3 is the 24. Opposite the 45 is the 25. So what I know from this is that angle, the purple angle UVT is going to be less than, because 24 is less than 25, it's going to be less than WVT, which means 6Z minus 3 is going to be less than 45. So I add the 3 and divide by 6. And I get Z is less than 8. But it wants a range here, so you have to figure out if it's less than 8, what does it have to be greater than? Well, this is an angle inside a triangle, and we know that no angle can have a degree measurement that's less than 0. So not only does it have to be less than 45, but it also has to be greater than 0. So 6Z minus 3 has to be greater than 0, which means 6Z has to be greater than 3, and Z has to be greater than 3 over 6, greater than, which is 1/2. So it has to be less than 8, but greater than 1/2. And to write that in one statement, I would put the smaller of the two on the left, so the 1/2 goes on the left. Z has to be greater than that, and Z has to be less than the bigger of the two, which is 8. So this time it asks for a range, and you're setting up the range of what it has to be bigger than and smaller than. Okay, these two examples on the bottom, so let's start with one. It says compare the given measures. So let's look at what we've got. We've got a shared side, so there's your reflexive side, and then there's two 12s, so this one is congruent to this one. So I've got two pairs of congruent sides, and then the other piece of information I have is the sides opposite. So 9 would be opposite this angle in here, and 10 would be opposite this angle in here. Because 9 is smaller than 10, the angle opposite 9, which would be angle EGH, is less than the angle opposite 10, which is angle EGF. 1B, again, reflexive side. So I've got this side here that's congruent, and these are both 9, two pairs of congruent sides. And then I've got 64 is opposite AB, and I've got 65 is opposite BC. So I know that 64 is smaller than 65, which tells me this side opposite 64, which is AB, is going to be smaller than the side opposite 65, which is BC. All right, this one says the angle of the swings in a circular swing ride changes with the speed of the ride. The diagram shows that the position of one swing at two different speeds. Which rider is further from the base of the swing tower? So remember, you're looking for either the Hinge theorem or its converse. In both, you need two pairs of congruent sides. So if you look at these as though they are triangles, so we got triangle A and triangle B. The tower is going to be the same height for both of them. So I've got that this one's congruent to this one. And the swing is the same distance away from that tower. Or sorry, not the same distance. Yeah, the same length. So now what you have to figure out is which rider is further from the base of the swing. So which one has the larger side here? You can see from the top here that this angle is smaller than this angle, which tells you the side opposite the first one is going to be smaller than the side opposite the second one, making this the larger side, which would be the larger distance. So rider B is further from the base than rider A, and that's your Hinge theorem. Number 2 says when the swing ride is at full speed, the chairs are furthest from the base of the swing tower. What can you conclude about the angles of the swings at full speed versus low speed? And this is, if it's further away, I know that angle at the top would be larger. So the angle of the swing at full speed would be larger than at the low speed. So we're going to skip the proofs on this, and we're going to go straight into the quiz part 1, which is just a review of what we talked about. So number 1 says compare angle ABC and angle DEF. So I know I'm comparing ABC to DEF. And you want to look at what you've got, what you're given. So on both of these triangles, they both have a 6 here. That's one pair of congruent sides. And they both have a 7. That's 2 pairs of congruent sides. The third side is the other piece of information we have. And 12, which is opposite angle ABC, is bigger than 10, which is opposite angle DEF. So I know ABC would be larger than angle DEF. Number 2 says compare PS and QR. So again, looking at your diagram, this time you've got a reflexive side, so that's one pair of congruent sides. The other is the 8, so I have 2 pairs of congruent sides. And the last piece of information I have is the angle in between them. So 80, which is opposite PS, is smaller than 100, which is opposite QR. So from that statement, I can say that PS would be smaller than QR, or PS is less than QR. And part 2, find the range of values for Z. So if I look in this diagram here, I've got one pair of sides that's congruent. I've got another pair of sides that's congruent. This is a right angle, which means it's 90 degrees, and this in here is 120 degrees. So I know the side opposite the 120, which is Z plus 23, is going to be larger than the side opposite the 90 degrees, which is 3Z plus 9. So I want to solve for Z. I'm going to subtract from Z on both sides. 23 is greater than 2Z plus 9. Subtract the 9. 14 is greater than 2Z. And divide by 2. Z is greater than, Z would be less than 7. So I know that's the top end of my range. So I know that Z has to be less than 7 because the smaller part of that is pointing towards the Z. But I have to know what it has to be larger than. And again, a side and an angle, neither of them can be smaller than 0. So I'd also have to say that these two sides would have to be greater than 0. So Z plus 23 has to be greater than 0. And also 3Z plus 9 has to be greater than 0. So Z has to be greater than negative 23. 3Z has to be greater than negative 9. And Z has to be divided by 3, greater than negative 3. So since I need the larger of the two, because if I pick a number that is less than negative 3 but still greater than negative 23, it doesn't work for this one. So I ignore the smaller of the two and keep that Z has to be greater than negative 3. So now I have the second part of my range. Z has to be greater than negative 3, but less than 7. So that's the end of what we're going to cover for 5, 6.